Okay guys, well we're just finishing chapter 4 test and we're going to move on to chapter 5. And the first lesson that we have in chapter 5 is solving systems of equations by graphing. So what is a system? A system is this little bracket that says two equations like y equals x plus 1 and y equals 2x minus 1 have one shared solution. Yeah, one shared solution. What does that mean? That means that they have one common x and y solution. Let's take a look at how we would solve these. First of all, let's just talk about identifying some solutions, right? If I have the solution 4, 1, or the x value is 4, and when the y value is 1, I would plug these into these two equations to see if it's true. When I plug it into the first one, if x is 4 and y is 1, will that equal 6? Well, it turns out that 4 plus 2 is 6. So yes, we know it's definitely a solution for this equation. Let's check and make sure it is for the other one. If I say when x is 4 minus the y when it's 1, will that equal 3? Well, yes, it does equal 3. So we know that this is the shared solution. There can only be one on this unless it's the same line, but we'll talk about that later. That it's true for both. So we know it is definitely the shared solution. True. Let's do it again. Okay, if I have the solution of -1, 2, will that, it's question mark, will that be the solution here? Well, we plug in what we know that x is -1 and y would be 2. Does that in fact equal 8? And it does. So we know that it's the solution definitely for this equation right here. But is it for this one? Because if it's not for both, it's not for the system. So we go ahead and plug this in, and we see that it is definitely not. It is a no for this one. So although it is a solution to the first equation, it's not to the second. Therefore, it's no. Both have to be equal, and it's not. So it's not a shared solution to this system. Go ahead and try this one on your own. Pause the video and then see how you do. All right, we plug in what we know and we see, does it equal? It equals for the first one. Drum roll, and it equals for the second. Therefore, it is equal to this system. It is the solution for this system of equation. Now, today we're solving by graphing. Well, what does that mean? Well, that means if we graph both of these lines, there should be one shared solution because it says it's a system. So I graph my first line using my y-intercept of -3 and my slope of 2/1, and I graph that line in purple. Then I graph my second line, use my y-intercept is 2, and my slope is -1/2. And I see that these two lines intersect at exactly one point that happens to be 2, -1. Now, what that means is if I plug it in to the first equation, it should be true, and it is. And if I plug it into the second equation, it is also true, and it is. So I can see it by graphing, and I can see it by plugging it in. So I know it is the one shared solution. Let's try it again. If I have these two equations, how would I choose to graph? Well, the first equation, I'm going to use y equals mx plus b. That's just a given, right? -3 is my y-intercept. My slope is 1/3. And I'm done there, right? My second equation, I could solve for y. That's completely possible. Or I can see that these divide so easily. Why not make a t-table and solve for my x and y intercepts? When I do that, I see that x is 2 and y is 4. I have 2 good points, and I can graph that line, and I see that they are the shared solution of 3, -2. Now again, I could have solved for y. If I chose to solve for y, then I would have had this equation, and I would have graphed it using my y-intercept of 4 and my slope of -2/1, and I still end up with the same shared solution of 3, -2. And of course, if I did the math and plugged them in, they would work. It's magic. So great. Go ahead and try this one. While you're doing that, I'm just so excited about this unit. When you talk about systems of equations, you really are talking about the magic that happens when you have two very difficult situations, but they have one shared solution. For example, you always hear like, oh, there's a train going 50 miles an hour from Seattle down to Santa Cruz. But there's also a train from Santa Cruz going 250 miles an hour to Seattle. When do they cross paths? And systems of equations can do that kind of thing. It's so great. Okay, you're probably done by now. Go ahead and check your work.